Namaste. In the shortcut video series of Polymath, this is the fifth video in which I am discussing the short forms to find out the partial fractions. What does it mean by partial fraction? First, if you take a fraction, if that fraction can be split into two or more than two fractions, it is nothing but the partial fraction. In the name itself you can see that. But you must know the basics of this partial fractions. Number one, the denominator containing non-repeated linear factors. Number two, the denominator containing repeated linear factors. Number three, it is the denominator is containing non-repeated linear factors or repeated linear factors or the factors that are of higher degree than one, that is second degree or third degree or something like that. And the fourth one is the denominator and the numerator will have the same degree, or the numerator is having more degree than the denominator, that is, it is an improper fraction. These are the four different types of partial fractions are there. And in this one, you must know the basic thing is that the number of fractions must be equal to the number of factors in the denominator. The number of fractions is equal to or less than the number of factors in the denominator. For example, if you take these two factors, there should be two fractions, corresponding fractions must be there. Okay, now there is a method for this to find out the partial fractions in the board level examination. But what is that we are going to learn in this shortcut video is that everywhere but not there. What exactly the meaning of everywhere but not there? Let us see that. Now, if you see this, there are the corresponding fractions will be containing the denominator as x plus 1, and here the denominator is x minus 3. This denominator is x plus 1. Our interest is to find out the numerator for this one. So, put x plus 1 is equal to 0 everywhere but not there. Put x plus 1 is equal to 0 everywhere but not there. What is it? Put x plus 1 equal to 0 means x is equal to minus 1. So write it there. 2 into minus 1 plus 3 divided by 1 minus 1 plus 1. You should not write this here. Everywhere but not there. So minus 1 minus 3. So what should it be? What should it be? Minus 2 plus 3. 1 by minus 4. So minus 1 by 4 into x plus 1. Coming to this, put x equal to 3. Put x equal to 3 or x minus 3 equal to 0. Everywhere but not there. Everywhere but not there. Put x equal to 3 there. This is 6 plus 3, 9. I'm writing that. 2 into 3 plus 3 divided by 3 plus 1. So it is nothing but 6 plus 3, 9 by 4. So plus 9 by 4 into x minus 3. It is done. It is done. So this is nothing but non-repeated linear factor because the power is 1. Power is 1. There is no repetition. Here x power is 1 inside. This x power is also 1. So it is a non-repeated linear factor. Now, if it is other than that, in this way, if the denominator is containing x squared minus 4 and it is factorizable, if it is factorizable, then it becomes x plus 4 divided by x plus 2 into x minus 2 into x plus 1 is equal to, write the three corresponding fractions, x plus 2, x minus 2, x plus 1. Now put x plus 2 equal to 0 or x is equal to minus 2 everywhere but not there. Everywhere but not there. So x equal to minus 2 means 4 minus 2, 2. 2 by minus 4. 2 by minus 4. I'm writing that. Minus 2 plus 4 divided by minus 2 into minus 2 plus 1. It is done. It is done. Now coming to this, x is equal to 2. Put x equal to 2 everywhere but not there. x equal to 2. 2 plus 4, 6. 6 by 4 into 3. 4 into 12, 6 by 12. It is 1 by 2. I'm writing directly. Mind calculation is important here because we are learning short forms here. Similarly, put x equal to minus 1 everywhere but not there. Put x equal to minus 1. It is 3 divided by, it is minus 1 plus 2. 1 minus 1 minus 2 minus 3. So final answer for this one is nothing but 2 by minus 4 into minus 1. 2 by 4. It is 1 by 2 into x plus 2 plus 1 by 2 into x minus 2 minus 1 by x plus 1. Done. See how many steps we wrote there? We wrote only one step in between to write the answer. That is what? Everywhere but not there. Now coming to this. You must be thinking like this, whether this everywhere but not there is useful in every type of factors. No. It is useful only when the denominator is containing the non-repeated linear factors like this. But sometimes it can be adjusted. I'm going to tell you that. Even if you know this everywhere but not there, even if you have one such factor, then the remaining can be easily find out like this. Now, it is nothing but 2x square plus 2x plus 1 divided by x into x square into x plus 1. X square into x plus 1. Now, it is a non-repeated linear factor. So, x plus 1, write it. Here power 2, power 1, 2 plus 1, 3. So there are 3 factors there. Here also 3 factors, 3 fractions. Here also you must have 3 fractions. So one is x, other one is x squared. Now remember, everywhere but not there, I said is to be used only for non-repeated linear factors like this. But it can be used even for this also where the highest power occurs. For example, you have x cubed there. You should not use that everywhere but not there for x square, but you have to use it for x cubed there. The highest power is to be used. Now, put x equal to 0. Put x equal to 0. Everywhere but not there. Everywhere but not there. X equal to 0 if you put. This is 0, 0, 1. 1 by 1. It is 1. Done. How simple it is. Done. But we cannot use it. We cannot use the same everywhere but not there, the short form in this case. But in this case you can use it. X plus 1 equal to 0. That is x equal to minus 1. Put x equal to minus 1. Everywhere but not there. Everywhere but not there. Minus 1 if you put 2 plus 1 3 minus 2 1. This is minus 1 whole square. So it is 1 only. Just check it out. X equal to minus 1. 2 plus 1 3 minus 2 1. That's it. This is 1 only. Now, we don't know this value. Let it be some a. Just see that. Let it be some a. Now I need the value of a. X equal to 0. We already used. X equal to minus 1. We already used. Put x equal to 1 then. Put x equal to 1. So, put x equal to 1 now. Implies. Just say this. 2 plus 2 plus 1 5. X equal to 1 we put 2. Is equal to x equal to 1 by 2. A by 1 plus 1 implies your a is equal to 5 by 2 minus 1 by 2, 2, 2 minus 1, 1. So a is equal to 1, done. Just say this. We've got all the fractions now. So what is that we did? We use everywhere but not there only. But in this case it should not be used. So wherever it is, it can be used. I used that everywhere but not there. I got these 2 values. And then with the use of these 2 values, I got the value of a by giving some value, whatever you like. But those values should not be repeated, like x equal to 0, x equal to minus 1 should not be given. Other values you give, and thereby you get the value of a. That's what it is. Now coming to this, if you see carefully, it is x cube minus x plus 1 by x plus 1 into x minus 1 whole square. See, the denominator is containing the denominator is containing x square minus x plus 1. X square minus x plus 1. This is x square minus x plus 1 divided by x plus 1 into x minus 1 whole square. Here you have one non-repeated linear factor. You have repeated linear factor. Repeated linear factors. How many factors in the denominator now? 1 plus 2, 3 are there. So you must write 3 fractions. So for that one, we are writing x plus 1 first, and then x minus 1, and then x minus 1 whole square we wrote. Now put x plus 1 equal to 0 everywhere. Put x plus 1 is equal to 0 everywhere but not there. X equal to minus 1. So write minus 1 here. 1 plus 1, 2 plus 1, 3. 3 by minus 1 whole square. Minus 2 whole square. 3 by 4 done. It is done. Now for the highest power of non-repeated, the repeated linear factor, highest power, you can make use of the same everywhere but not there. Here also, put x equal to 1. Put x equal to 1 everywhere but not there. X equal to 1, 1 minus 1 plus 1, 1 by 1 plus 1, 2. So 1 by 2. It's done. Now, you have to find out the value of a here. You have to find out the value of a here. Now, put x equal to 0. Put x equal to 0 here, please. Put x is equal to 0. Implies 0, 0, 1 by 1 is equal to 3 by 4 into 0 plus 1. Put x equal to 0. A by minus 1. Put x equal to 0. 1 by 2. So, we need a here. What is a? What is a here? Bring it to the other side. This is 3 by 4. 3 plus 2, 5 by 4 minus 1. 5 by 4 minus 1, please. 5 by 4 minus 1. 1 by 4. That's it. You got a value as 1 by 4. See, even though we are not in a position to use a shortcut everywhere but not there, we got those values wherever it is applicable, and wherever it is not applicable, then we got the values like this. It is done. So how many steps we used? We used only 1 or 2 steps to do this. Let us take similar problems now. Let us take similar problems now of other model. 3x cube minus 8x square plus 10 divided by x minus 1 whole power 4. Interesting problem. It is an interesting problem because the denominator is containing linear factor repeated. Linear factor repeated. Whenever this type of problem comes, whenever this type of problem comes, it is very easy to work out. How the denominator is containing only one factor which is repeated. Only one factor which is repeated. Then proceed like this. It will be very simple. Put x minus 1 is equal to y. Implies x is equal to 1 plus y. Now write this. 3 into 1 plus y whole cube minus 8 into 1 plus y whole square plus 10, and the denominator becomes y power 4. This is the advantage. See the advantage. What is that happening to the denominator? It is becoming y power 4. And if you expand the numerator and if you split it, you will get the final answer. Now, let me split it. 3 into 1 plus y cube plus 3y square plus 3y minus 8 minus 16y minus 8y square plus 10 divided by y power 4. Just see this. It is 3y cube I am writing it by y power 4, and it is 9y square minus 8y square plus y square by y power 4. It is done, and it is 9y minus 16y, 9y minus 16y minus 7y divided by y power 4, done, plus 3 minus 8, 13 minus 8 plus 5 by y power 4, done. It is nothing but 3 by y, please. 3 by y. What is y here? X minus 1. 3 by x minus 1. It is 1 by y square, 1 by x minus 1 whole square, minus 7 by x minus 1 whole cube, plus 5 by x minus 1 whole power 4. Just see the steps what I have written here. Whenever the denominator is like this, then take it as y and split it, and after splitting, substitute the value of y. That's what it is. Now, let us see another model. X square plus 1. This is done, please. X square plus 1 divided by x square plus x plus 1 whole square. X square plus x plus 1 whole square. What I'd like to tell you here, very important thing. What is the purpose of doing all this? Splitting a given fraction into 2 or more than 2 fractions. That is our purpose. Whatever the method you follow, whether you follow the board method, whether you follow the shortcut what I said everywhere but not there, or whether you use another method with your talent or with your intelligence, whatever the method you do, but finally it should be split into fractions. So here also, without applying any methods here, I'm just adjusting the numerator to get the fractions. See here, what is that I'm doing here? What I'm doing, I'm creating the denominator in the numerator. I'm creating the denominator in the numerator. Denominator term, not whole squares. I need only the base. That's the reason why I added x and subtracted s. X added, x subtracted. Split it now. Split it. If you split it, what is that you're getting? If you split it, what is that you're getting? Just see that. Getting cancelled? 1 upon x square plus x plus 1 minus x upon x square plus x plus 1 whole square. Done. It is done without using any method, with a simple adjustment of the numerator. We did this problem. Just understand that. Understand the different techniques here. Next one is 2x square plus 3x plus 4. 2x square plus 3x plus 4 divided by x minus 1 into x square plus 2. Okay, now this problem is 6th one and this is 7th one. Now let us see. Here you have to observe that the denominator is containing non-repeated linear factor. Denominator is containing non-repeated linear factor. Comfortably you can make use of everywhere but not there. So let me write that first. X minus 1. Put x equal to 1 everywhere but not there. Put x equal to 1. 2 plus 3. 5 plus 4. 9. 9 by 1 plus 2. 3. 9 by 3. 9 by 3. 3. Mind calculation. It's very important to improve your mind calculation, particularly in the objectives. That's what we did, because now we reach to the 7th problem now. By now, you must train your brain to get the value directly like this. I put x equal to 1, 2 plus 3, 5 plus 4, 9 by 1 plus 2, 3, 9 by 3, 3 plus, now here, this is, you cannot find the factors of this. You don't have real factors for this one. You don't have real factors for this one. That is what I mean to say. You don't have rational factors, I must say like that. Real factors means if you have a square minus b square form, you can write it as a plus b into a minus b, but you don't have that. That's the reason why the numerator contains the form of ax plus b divided by x square plus 2. Follow this carefully, please. That means if the denominator is a quadratic, numerator will be linear of first degree. If the denominator is a cubic, then the numerator will be a quadratic. If the denominator is biquadratic, then the numerator will be cubic. That's what you have to understand. Now what I'm doing, I'm putting x equal to 0 here. X equal to 0. So put x equal to 0. What is that again? Just check. 0, 0, 4. Minus 1 into 2, minus 2. 3 by minus 1. 0 plus b by 2. So what is b now? What is b? Minus 2 plus 3, 1. B is equal to, this is minus 2 plus 3, 1. B is equal to 2. Got it? You got it. Now, this is the substitution we did to get the value of b. Now, how it will be written? 3 by x minus 1 plus ax plus 2 by x squared plus 2. X equal to 0 is done. Now you cannot give x equal to 0 here because we need a. If you give x equal to 0, a also becomes 0, a into 0. That is why put x equal to 1 cannot be given because it is already used and you cannot give that. So x equal to minus 1 can be given. So put x equal to minus 1. Then 2 minus 3 minus 1 minus 1 plus 4 3. X equal to minus 1, this is minus 2, this is minus 2, this is 3. Minus 2 into 3, minus 6. Done. Now coming to this, 3 by minus 2, substitute here, 3 by minus 2 plus minus a plus 2 by 1 plus 2, 3. Now this is minus 1 by 2. This is 3 by minus 2, yeah. And this one is, we put minus 1 there, 2 plus 4, 6 minus 3, 3, correct. So, it is minus 1 by 2, minus a plus 2 by 3 is equal to minus 1 by 2 plus 3 by 2. How much is it? 2 by 2, 1. 2 by 2, 1. So, it is cross multiply this. 2 by 2, 1, 3. A is equal to 2 minus 3. A is equal to minus 1. A is equal to minus 1, please. That's it. That's it. You got A value now. So put this A value here. Got it. Got it. That's it. So see how many steps we have written here. Only 2 to 3 steps we have written. That's it. Now let's see the next problem. Next problem is x cube divided by x minus 1 x plus 2. This is of different model. Why? Very important thing to be observed here. What are the methods we follow? What are the methods we follow for partial fractions, What are the methods we follow for partial fractions, We apply those methods only to proper fractions, not to improper fractions. What does it mean by proper fraction? Proper fraction has the degree of the numerator less than the degree of the denominator. Improper fraction, degree of the numerator is equal to or greater than the degree of the denominator. Then it is said to be improper fraction. So if you are given an improper fraction, you have to express it as an improper plus proper, then only you can apply the principles of partial fractions to proper fractions. So what all the methods we follow is to be applied to proper fractions only. Like very simple example, numerical example I'll take. 7 by 2 is there. It can be written as 3 plus 1 by 2. This is improper. This is proper. For this only the principles can be applied. So this is quotient. This is a reminder. This is the divisor. In that form it is to be written. But the technique here, see here. X into x here, x squared. Here numerator, x cube. X cube by x squared. X cube by x squared, x written. But when you divide, when you divide cubic with quadratic, you will get x plus some constant. That constant we don't know, written. Written. Now, apply everywhere but not there. Apply everywhere but not there as usual. Put x equal to 1. Put x equal to 1 everywhere but not there. X equal to 1, 1 by 1 plus 2, 1 by 3. Done. I'm writing directly now because you are habituated by now. You must have understood by now. Now putting x equal to minus 2 everywhere but not there. X equal to minus 2, minus 8 by minus 3, 8 by 3. Done, please. What is that remaining now? Only a is remaining. Only a is remaining. Very simple. Put x equal to 0 now. Implies 0 is equal to 0 plus a. So 1 by the 0 minus 1. 0 minus 1 minus 1 by 3. This is minus 1 by 3. And this is 0, 8, 4 by 3. So what is a now? What is a? This is 3 by 3. This is 1. A is minus 1. This is the value of a. Done. See how many steps we wrote. We wrote only one step in between to write the answer. This is what the method. This is what the method. Let us see one more. X cube divided by x minus 1, 2x minus 1 into x minus 1 whole square. This is also an important model like this only, and now you will perfectly understand how I wrote this. Here, if you expand this, you will get x square term here. 2x into x square. 2x cube, numerator x cube. Improper. Numerator degree, denominator degree are same. But x cube by 2x cube. X cube by 2x cube. 1 by 2. That's it. No need to write like this. Because you got x here, you are writing plus a. Now, here, constant. Directly we wrote. That's all. Now, everywhere but not there. Everywhere but not there. 2x minus 1. This is x minus 1. This is x minus 1 whole square. How many fractions we have to write? This is power 1, power 2, 1 plus 2, 3, 1, 2, 3 fractions we wrote. Now everywhere but not there, put x equal to 1 by 2. This is 1 by 8. Put x equal to 1 by 2. This is 1 by 2 minus 1. 1 by 2 whole square, 1 by 4. 1 by 4. Put x equal to 1 now. Put x equal to 1. You should not apply for this, but for the highest power you can use. X equal to 1 everywhere but not there. Put x equal to 1. 1 by 2 minus 1. 1. Done. Done. Now, what is that? We don't know this. Put x equal to 0. That's it. Put x equal to 0. Implies this is 0 is equal to 1 by 2. And here it is. Here it is. Put x equal to 0 here. This is 1 by 2. Minus 1 by 2, 2 times here 1 by 2, this is 0, 1 by 2 into minus 1, minus 1 by 2, plus a by minus 1, put x equal to 0, this is plus 1, getting cancelled, a is 1, done. See that, it is done. We are using only everywhere but not there, we are able to solve all this with the help of suitable substitution. With the help of suitable substitution. Now let us see one more. This is, and you must have a clear idea where these partial fractions are used. Partial fractions are used in indefinite integration. Indefinite integration and indefinite integration also. And overall, the partial fractions will be used in integration, and not only that, but it will be used in binomial theorem also. Binomial theorem, to find out the coefficient, we write the power series. There also we make use of this partial fractions. So partial fractions are useful in integration. Number 2, binomial theorem. So here I've taken one problem from integration just to show you How this is useful in integration? X by x square minus a square into x square minus b square dx. Just see this. Here, what I'm doing, I'm not applying any method of partial fractions. I'm just thinking like this, how I can shift, how I can transform, how I can modify this to the standard format of formula form. Anti-differentiation formula. Anti-differentiation formula. How it can be done. What I'm thinking, now I'm thinking of writing the numerator as a difference of these two. Let us check. Let us check. Integral of x into, keep it as it is. I'm writing x square minus a square minus of x square minus b square. Just see that. I have created that. But after creating, I'm checking out what is the extra term I wrote in the numerator. X square getting cancelled, and this minus a square plus b square. So I wrote b square minus a square extra there. That is why I have divided. Now x square getting cancelled, b square minus b square minus a square getting cancelled. Only x remains. So I adjusted it like that. Now split it. Split it. This is there already. So let us write that outside. 1 upon b square minus a square integral of. Split it please. X square minus a square getting cancelled. What is that remaining? X dx divided by, this is getting cancelled, x square minus b square minus integral of x. Split it please. These two getting cancelled. X dx divided by x square minus a square. Now in my previous videos I discussed तीन मार which is nothing but तीन मार 3 there, integral f dash x by fx log mod fx. See here, what is the derivative of this? 2x. What is the derivative of this? 2x. Of course 2 is not there. Multiply with 2 and divide with 2. So I can write this in this way, 1 by 2 b square minus a square f dash x by fx log mod fx ln mod of x square minus b square, and this is also, I wrote 2 here outside, f dash x by fx again, it is also same. Done please. That's it. See how many steps I wrote here. This is the problem given. 1, 2, final answer. Only 2 steps I wrote. You have to practice it. You have to think in that way. So I have not used any principles of partial fractions here. So the purpose of partial fractions in integration is to bring the given problem or given function to the standard format form. Formula form otherwise. F dash x by fx. Now let us take one more such problem and we will work it out. That is, next one also I have taken on the integral only. See what makes the difference between the previous problems and this problem is this. Integral of x square plus 1 divided by x square minus 1 into x square minus 2 into x square minus 3 dx. Then you must be thinking like this. You said this short form everywhere but not there is to be used only for non-repeated linear factors, but it is not a linear factor. Power 2 is there, hence we cannot apply that short form here. No. Here, very simple thing you have to understand. Everywhere you have x square. Other than x square, no other terms. Other than x square, other terms are not lying. Like what are the other terms? X term, not there. All are x square only. Consider x square as y. Y means it becomes linear in this case. Apply the same concept everywhere but not there. What is it? Integral of x square minus 1. This one x square minus 2. This one x square minus 3. Put x square equal to 1. Put x square equal to 1. Everywhere, but not there. 1 plus 1, 2. By minus 1, minus 2. This is minus 2. So 2 by 2 by 2, 1. Check it out, please. X square 1, 2 by minus 1, minus 2. Minus 2 into, this is minus 2 by minus 2, 1. Correct. It is correct. Similarly, here also, put x square equal to 2. Put x square equal to 2 everywhere, but not there. This is 2 plus 1, 3. 3 by 1, 3. 3 by minus 1. Minus 3. Done. Put x square equal to 3. Put x square equal to 3. Everywhere, but not there. X square equal to 3. 3 plus 1, 4. 4 by 2, 2. 2 by 1. 2 by 1. 2. Done. That's all, please. Now standard format you got. Standard format 1 by x square minus a square. 1 by 2a ln mod of x minus a by x plus a. Minus 3 by root 2 whole square. 1 by 2 root 2. 3 by 2 root 2. ln mod of x minus root 2 by x plus root 2. Plus 1 by 2a. This is 2 root 3. ln mod of x minus root 3 by x plus root 3 plus c. Done. See how many steps we wrote. This is a given problem. This is a partial fractions. Next step is the answer. So by seeing this problem, you'll be thinking it is a difficult one, but not at all. It is simple like this. Let us take a last problem just for you to make better understanding, not of integral, but simply partial fraction. It is x cubed divided by x minus a, x minus b, x minus c. Think whether it is proper or improper fraction. Numerator x cubed, denominator also x cubed. It is an improper fraction. It is an improper fraction. So x cubed by x cubed, 1. Done. Rest all very much short form. What is that? Put x equal to a everywhere, but not there. So what is that you get in the numerator? A cube divided by a minus b into a minus c. Next, x minus b, please. Put x equal to b everywhere, but not there. So b cube divided by b minus a into b minus c. Next, put x equal to c everywhere, but not there. So x minus c, c cube divided by x minus a means c minus a, c minus b. Done, please. That's all. Only one step to write this. Only one step to write this. Like this, you can find out the partial fractions with the technique of everywhere but not there. And in the next video, we'll be dealing with the integration of partial fractions. Integration of partial fractions like this only. In the next video, I'll be solving integral problems related to partial fractions. Namaste.